So here we go. Oh my gosh. Wonderful. We're on page 15. We dealt with arithmetic series last time with the S notation, where really they're all kind of the same thing after a while. We just taught you on the warm-ups. We're good with that. But what we now need to do is look at some of these problems in sigma notation. First of all, we're going to write a little bit below the title, but not just yet. I want to take a look at that first example. The sum as I goes from 1 to 40 of 3i minus 1. This is going to be a pain. Why? You already know about sigma notation. What's going to make this a pain? You got to plug in 40 numbers. There's got to be a quicker way to do this. Let me start doing this problem, though. Plug in 1. What do you get when you plug in 1? 2. Right? 2. Plug in 2. What do you get? 5. Okay. Plug in 3. What do you get? Plug in 4. What do you get? What do you notice about this series? Plus 3. It's an arithmetic series, which means we can use our arithmetic series formula to deal with this. There's actually a nice little shortcut we're going to see in a moment. But before we do that, in general, no, I'm not. Well, first of all, I should add the plus ... to this because it's not stopping at 11. It's going on until we get to 40 terms. In general, we need a quick way of being able to tell if something in sigma notation is arithmetic. And here's our rule. If the stuff inside the sigma is just involving multiplication or addition, or subtraction, that's kind of the same thing, it's going to be arithmetic. Or to write this a little bit more formally, any series in the form the sum as I goes from some number to some other number of something like a times I plus b, or something like that, will be arithmetic. What I'm really trying to say here is if we don't have a square, don't have a cube, don't have a variable in the denominator, don't have a variable in the power. This is a terrible way to say it, but if it looks simple inside the sigma, it's going to be arithmetic. Look at all of the sigmas on the page right now. Those are all going to be arithmetic because they're all in this form of some number times a variable plus or minus some other number. These are all going to be arithmetic. So with this in mind, I'm going to try to use my arithmetic series formula, which I know is S sub n equals n over 2 times a1 plus an to deal with this. This first example, this is arithmetic. How many terms are there? 40. Okay, so S sub 40 is going to equal 40 over 2. Do I know my first term? 2. And yeah, I see that in the series that I wrote up, but where did I get the 2 from? Plugging in that first number, plugging in 1. Now, I need to get my last term. Do I have my last term? No, so I need a formula to get my last term. There are 2 ways we can get this formula. The long way is doing exactly what we did before. We can look at our series and say, oh, there's a common difference of 3, use our arithmetic sequence formula, but there's a shortcut to do this. Raise your hand if you have an idea how I can quickly get that last term. Jack? We already have a formula. This formula can tell us any term we want, so why don't we just plug 40 into that and we'll be set. So our first term was just 3 times 1 minus 1, just the 2. Our last term, all we need to do is plug 40 in there. 3 times 40 minus 1, what is it? 119. We don't need to create a separate formula. We already have the formula, which saves us a step actually with this. So go plug in and let's get an answer. I have a rather large number. Marissa, do you have an answer?
2,420.
Yep. Our arithmetic series works for series written in sigma notation as well, as long as the series is arithmetic. And we're just using the formula in a slightly different way. We're getting the last term in a different way by just plugging into the formula we see. I would like to see if you can do that second example on your own, and please do not go on to the bottom yet, because there is something a little different we have to deal with on the bottom. How many terms in that next example? Good. Keep going. Alex, you have the first term? What do you have? That's the number I'm looking for. So the first, how did you get -3? We're just plugging in 1, plugging in that lower limit. 2 times 1 minus 1, -3. And Niles, do you have the last term? And where's that coming from? That'll work. -2 times 26 minus 1, -53. Okay, so I think we have everything we need now to go use our series formula. S sub 26 equals 26 over 2 times -3 minus 53, I believe should be your formula. Ben, do you have that for the formula?
Yep.
Do you have an answer?
-728.
Perfect. Does this make sense? The homework tonight is a mix of the arithmetic series like we already dealt with, where I write it out for you and say find S sub 20 or whatever, and then them written in sigma notation. Again, what we're doing right now only works, though, if the sigma stuff is arithmetic. We saw a lot with the sigma notation homework 2 nights ago, where the series created was some kind of random-ish looking pattern. Our formulas wouldn't work for something like that. The only way we could handle those right now is truly by writing out all the terms and adding them up. But if it's arithmetic, we can work with this. On the bottom, is this example arithmetic? Absolutely it is. Just multiplication and addition inside the sigma. So that is arithmetic. And how many terms are there? 40? 37? Okay, so first of all, why is it not 40? It starts with 3. If it doesn't start with 1, we actually need to think a little bit about how many terms there are going to be. So let me ask you this. If we went from 1 to 40, how many terms would there be? From 1 to 40? Louder. There are 40 terms. So if instead of going from 1 to 40 with 40 terms, we went from 2 to 40, how many terms would there be? 39. So 3 to 40? 38. There are 38 terms. Now, those of you who did not say 40 said 37. Where were you getting 37 from? Just subtract, which is actually almost how we're going to get this. Problem, though, is if you subtract, you get 37. I want 38. The reason it's not totally correct is because if you subtract, it's also kind of like we're ignoring the bottom number and not plugging in that number. And I do want to plug in that number. To find the number of terms, all we do need to do is subtract the top minus the bottom, but then just add 1 to that answer. So what's going to go in the box on this page to find the number of terms in a series in sigma notation? We'll do the top number minus the bottom number, but then add 1. We don't need to do that if we're starting with 1, but if we're starting with any other number, yeah, we do need to use our formula to figure out the number of terms. Okay, the first term. Shall I go and plug in 1? No, I shouldn't. What should I plug in? 3. Plug in your lower limit. So we're going to do 3 times 3 plus 4. What was that? 13. The last term. Shall I plug in, what should I plug in? 38? 40? There are 38 terms. However, according to our sigma formula, the last term we get by plugging in that upper limit, so we are going to plug in 40. We're going to do 3 times 40 plus 4, which is what? 124. Well, I'm going to do S sub, technically I should say S sub 38 because I am adding up 38 terms. And I'm going to say this is 38 over 2 times 13 plus 124. Go to the calculator, finish that off, and then do that last example on your own. And then actually that's all I have as far as new stuff goes. Maddie, how many terms are there?
24.
Yep, where did you get that from?
33 minus 10 plus 1.
Yep, and make sure you do include that plus 1. That's usually a common mistake that I see people do. It's 33 minus 10 plus 1. There are 24 terms. Selma, how did you find the first term? Plug in what to our formula? Plug in 10. Plug in that lower limit. Plugging in the lower limit will always give us the first term. You should get negative 3. And Jess, you have the last term. Yep, by doing what?
33 minus 10 plus 1.
You don't mean that. I think you mean plugging in 33 to the formula, perhaps?
Yeah,
oh.
My bad.
Oh, good. So like negative 26. So I think S sub 24 should be 24 over 2 times negative 3 minus 26. I am getting negative 348 for that. Does this make sense? Okay. So where we are going with this, we have 2 more days of this unit. We've talked about arithmetic sequences and geometric sequences, just the patterns. We've talked about arithmetic series. What has to come next? Geometric series. We're going to deal with that on Monday. Then on Tuesday, there's actually a different type of geometric series that we're going to spend a little bit of time on, and then we're done. We are going to review on Thursday and take a quiz, and Marissa and Jack, I'll talk with you. I've got some ideas we could skip the quiz. We'll talk. because you're not going to be here on Thursday. And then our test is on Friday of next week with all of this stuff. I'll give you the review packets Monday. I definitely want that test Friday because then we don't have anything hanging over the long weekend and all that good stuff. So, let me push the power button. Yes, we're going to push the power, not power button, the stop